Okay, in this problem we're asked to solve this absolute value inequality. Okay, a lot of stuff going on here. We're going to write our answer in interval notation just like we did in the last problem. Okay, how do we work with something like this? So, what we're going to do first is we're going to isolate the absolute values. We're going to get that thing by itself. So we're going to have, I'm going to subtract 6 from both sides. So that's going to give me 15 minus 6. That's going to give me 9. Okay, now I'm going to divide by the 3. So that'll give me the absolute value of x plus 3 is greater than or equal to 3. Now again, because the 3 was positive, I didn't change the sign of the inequality. If this 3 would have been negative, I changed the sign. It doesn't matter whether this 9 is positive or negative in terms of the way that the sign faces. Okay, now when you work with inequalities, you have to figure out, is this an and or an or statement? Well, when the inequality is opening up, so when my inequality is opening up towards my absolute value, that's going to be an or statement. In other words, if we have a number, okay, so if I'm looking for all the numbers greater than or equal to 3, well, numbers that are larger than 3 would work, right? So numbers that are larger than 3 would work, but also numbers, because I'm taking the absolute value of it, then also numbers that are less than negative 3, like negative 4, absolute value of negative 4 is indeed larger than or equal to 3. Because when we take the absolute value of negative 4, we end up with positive 4. So that's going to give me all the ones over here. So that'll be an or statement. Okay, so we're going to split it up as an or. If it was facing the other way, it would be an and statement. So in other words, if we had the absolute value of some number is, let's say, less than or equal to 3, well, that means the negatives up into negative 3 and the positive up to 3, these would be the guys that would work, right? Like negative 2 falls in this range, and negative 2, the absolute value of that is 2. That's clearly less than or equal to 3. Now, but if I go outside of these bounds, you'll notice that if I plug any of those numbers in here, it wouldn't work. So this, since we're including this this area where they're like stuck together in there, this is going to be an and statement. Okay, so ors are when it faces your absolute value, ands are when it faces away from your absolute value. Okay, so it's going to be an or statement. Now what I'm going to do is I'm going to get rid of the absolute value sign, the following. There's 2 ways to think about it. I think the fastest way, the easiest way for me to think about it is like this. Absolute value means positive or negative. So by definition, we could say x plus 3 or negative x plus 3. Now I'm guessing that you may have learned it so that you just flip the other side and make it negative. I think this is a little bit easier to remember, but it gets you to the same spot, because what will happen here is if I multiply both sides by negative 1, I'll get x plus 3 is less than or equal to negative 3. So it's very likely that you might have learned it this way originally and just bypass this step. But I just remember I just do the positive version of it and then the negative version of it, and that helps me remember which one flips the sign. Okay. So again, it's your call how you want to do it. Now I need to solve each of these. Again, they're an or statement. So here I'm going to subtract 3 from both sides. So I'm going to have x is greater than or equal to 0. And over here, subtract 3 from both sides, x is less than or equal to negative 6. Okay, so let's plot those both out. So x is greater than 0. Well, that would look like the following. We'd have 0. We'd have a closed circle there, right, because we're including, and everything larger than that because we open up towards our variable. This one here I'd have negative 6. Again, a closed circle. And I want everything that is to the left of that, and that's all of these guys right here. So now I can have either this or this, which means that if I put them both together, here is negative 6, here is 0. Because it's or, I can use one or the other. Okay, so both of them work. So or is just wherever we see it, and is where they overlap. So here we've got an or, so everything from negative infinity to negative 6 will work, and everything from 0 up to infinity will work. Any of those numbers in those intervals. So I've got two separate intervals here. I have one, we go from, on our intervals, we go from left to right. So I'm going to go from negative infinity to negative 6. Now, infinities aren't really numbers. Okay, you can't do things with infinities like add or subtract them or multiply them by other integers or real numbers. So we never include the infinities. Now the negative 6, we're going to include it because negative 6, it turns out it works in this problem. So since we're going to include it, we're going to use a bracket. Then our other interval, so again, I'm just writing each of these two intervals. Our other interval is from 0 up to infinity. Now, to show that we're going to put them together, we're going to use this union symbol, or the cup symbol, and it'll look just like that. So this describes all the numbers here, this describes all the numbers here, and this is going to be our answer to this problem.